Howdy, howdy, howdy. There we go. Oh, Link's downstairs. Ah. Yeah, we got some people in here. That's good. Did the ping not go out? Yeah, there it is. Okay. Weird. All right. Slow fade. Haha. I'm gonna forget about that. So, bye-bye. Alrighty, how are we all doing today? The handful of you that are here and the rest will trickle in shortly, I'm sure. Damn it. Full screen, please. Thank you. Excuse me. All right. So we are at the beginning of December here. That means that it is almost time for the year to be done. So you all got the announcement yesterday? Every time, 10 o'clock, I swear to God. It's like a schedule. Oh, that's good. Children. Anyway, so you all got the announcement that went out yesterday. Basically, your SRS documentation is going to be your final documentation. Also going to be your last homework assignment, your final exam, etc., etc. Basically, it's just wrapping everything up. We can go through all of this on Friday. We, again, are going to do probably a Zoom session to try that out. It's going to be pure group work time. I'll send out an announcement to really clarify the point and all that. Basically, I want your teams to come up with a plan and to get going working on this, and I'll pop in and out of the various breakout rooms that I'm going to create for you all. But yeah, make sure you read through this pretty carefully. I've tried, honestly, to make it as clear as possible for what I'll be expecting. And I even put a rubric there at the bottom. So if you're not sure what I'm grading you on, here you have a very handy checklist with point values and even some sample copy and pastable markdown code. And the one thing that I will show you before we go to the actual lecture here is I found this markdown prototyping tool on the web, and basically it just does a live um, com not compile, interpretation of your markdown code. Obviously, you could probably do this in like VS Code or something like that. But if you don't want to write it locally, check it into GitHub, see if it works, fix it, check it in again, etc., etc. You could just build it in here, and then you can actually see like, the table's working, and it doesn't look like this horrible mishmash of weird characters. It actually, hey, cool, looks like a table. So if you want to try that out, feel free to use that editor. Um, but yeah, like I said, just read through this, take some time to think about what you have to do. Hit me up with some questions on Friday if you have any. And then the one point that I really do want to stress here is that this semester I've been very kind of nice about late submissions. For this one, there's not going to be any late submissions accepted because the weekend I have to grade, and then basically I think it's Monday or Tuesday, all the grades are due. And if I don't go get those in, you all don't get a grade, basically. So I've given you additional time for the final deliverables. But yeah, check it out. Let me know if you have any questions. It shouldn't be that hard if you actually read through it, I would think. Just some revisions and a little bit of adding some stuff here and there. Again, you don't have a final exam to study for in this class too. So hopefully that's beneficial for you all. All right, I already had the notes. I didn't need to do that. I needed to click on the pointer. Thank you. Okay, so we talked about this last time, right? Exhaustive testing, kind of left off here. We're going through that verification and validation phase of development. And the point was made last time that it's pretty much impossible to exhaustively test a program, right? And I gave you this example here. It would take many, many years just to exhaustively test the integer space for two variables, let alone more than two. So the kind of the goal with testing and why we're doing it and why I'm harping on it so much is that you're basically trying to achieve the objective that your project is doing what you are saying it is doing, saying that it is doing by your requirements and by your artifacts. Right? And again, that goes with user acceptance, user trust, customer trust, so on and so forth. Basically, you're proving your software works. But with testing, you want to kind of hide, or not hide, but you want to get away from this 600 years to test your program. So what we're going to have to do is be smart about how we test things. All right, so how can you find the largest number of errors or bugs or problems, or maybe they're not even bugs, maybe they're performance issues. But how do you find those with the least amount of time and the least amount of resources? So again, software engineering. If you take anything away from this class, the keyword will be trade-offs. What is the trade-off that we have to make in testing to have it be useful, but still attainable and achievable? So with testing, they're in dire need of coffee today. You have many things to test, right? And that goes with it's going to take a while. You have all of your source code. You also have all your requirement specs, your design specs, any of your other artifacts you've developed, obviously your source code. This all is part of the whole process. And again, remember, verification is going to be the side where you're more so testing internally that you have built the software according to your own specs. The validation side will be that it is accepted by your customer in the real world using, maybe their specifications or real world environmental data. But all of that is going to factor in here, right? So when we start doing testing, we have to start talking about building up test suites, which again are groups of test cases, usually focused on some particular aspect. Maybe a test plan, which will outline everything that you have to do for testing. Any tools that you may need for that, right? We've looked at JUnit and Travis CI so far, but there are so many testing tools that are out there. And, they can be manual or automated. And again, I would honestly recommend for you all, if you're still freaking out about that final deliverable, do your testing manually, right? Don't screw around with JUnit and spend hours and hours and hours trying to build up a testing framework. Just write it down and test it manually. Yes, it works. No, it doesn't. Okay. That's the easy way out. But with that, you have to build up your test cases, right? And those test cases are going to be what are you testing? What requirements is it linked to? What is the input data? What is the output data? What did you actually see? Based on that, does it pass or fail? Right, so that's what goes into a test case. And that's what that table that I provided to you will demonstrate. You have to fill all those blanks in. So let's look at a kind of a graphical testing model here. So let's say that we want to perform some kind of a testing procedure, right? This class is all about procedures and processes. So we're going to test some software. Well, we have to configure it, right? So we have to configure your actual application to support testing. You might have to configure the testing framework. Again, you configured Travis, you configured JUnit, you configured your simple calculator application. Basically, you have to configure everything to get it ready to be tested. And then you will perform the actual test, right? Run your JUnit tests, do your manual testing, do a code review walkthrough, go through line by line. Do we meet our requirements, yes or no? With that, you're going to then evaluate what you see. So I may have a list of everything passing. Well, that might be kind of a weird code smell that you get, right? If everything passes on the first try, what did you screw up, right? There's that weird kind of um, feeling that you maybe didn't test the right thing there. Or you start seeing a bunch of failures. What do you do then? Well, if I see that all of these failures are occurring, say at the user input level, we start debugging that, right? So you start doing like trace debugging, where you enter a bunch of print statements and see what's happening. Or you do user testing, or you do GUI testing, right? It just kind of depends on what you have to focus on. But the key is that you have to debug the problem, push the correction back into the system, depending on your software process. You go back and you re-implement it, redo your unit testing, redo your integration testing, go through the whole cycle again until you have software which is valid. You also might have something called a reliability model, and this isn't really something we're going to be getting into too much in this class, but basically you can predict how reliable your software is based on kind of the results of testing that you're seeing, based on typical inputs and outputs that you might be seeing. You can basically build up a model of your software, and then you can maybe guarantee a 99% uptime or something of that matter. So I've got some guidelines for you here, and these are all basically quotes from The Art of Testing. So the first one, necessary part of a test case is the expected inputs, or sorry, the inputs and the expected outputs. So that is your test oracle. It is telling you if your test case passes or fails. If you don't know what you're testing, you don't know if it fails. It should be self-evident. A lot of these will probably be common sense, but they're good to spell out because if you're trying to quickly test something, it's very easy to overlook a lot of these. All right, second and third kind of go together. Avoid testing your own programs. If you are a programming organization, avoid testing your own programs. Basically, remove that bias from the testing procedure. Bring in another department that is focused on quality assurance. Subcontract somebody who has experience with your product, whatever you have to do to make that as unbiased as possible. Then when you get a test report, and whether it's internal or external, go through it, actually give it the time that it deserves to be looked at, right? Why do all these test cases fail? Is there some weird link between another module and this one? Is this as a result of an integration test, a system test, a customer test? What has to be fixed? Thoroughly inspect that and actually figure out what the problem is and go back and fix it, right? Again, a lot of these are hopefully common sense, but it's not always the case. Fifth one here, write your test cases for invalid conditions. And this is, again, that counterintuitive, try to break your program type of situation, right? So if you're programming your software, and let me lost something over here, just checking my stream settings, make sure that you can actually break the program as well as to show it working correctly, because if you don't show it not working, how do you know if there's a failure here? All right, so basically write for those conditions which you would not necessarily expect to see, because I can guarantee you a user will find some way to enter in an invalid value or get into an invalid state. It's just the way of the user. All right, some more that we've got here. Number 6 honestly goes with number 5. Basically, try to figure out if you can coerce your program to do things that you didn't design it to do. Super easy example of this is if you're writing a 3D video game or even a 2D one. How many times have you clipped through the wall or fallen through the floor because you walked into a wall at just the correct angle where the collision detection can't handle it and it just lets you pass through? Yes, you have a collision layer on that wall, but somehow at that joint between these two surfaces, it's just blank space. Or maybe you forgot to apply a collision box to this particular object, right? There's always going to be somebody who breaks your system, either intentionally or unintentionally. And you don't want surprises once things have been released. That's how you get into the horrible realm of having to fix things after they've been released. Don't make throwaway test cases unless if your program is throwaway, meaning that don't make useless test cases. That's kind of the point that I made in your SRS document that I put out last night. Useless test cases, useless requirements, they do nothing for you other than add extra effort, extra time, and it's just not fun. Can you all hear me? There we go. Okay. Sorry, I was looking at the wrong setting there. I thought I had 0 volume. Yeah, so next one, don't... Holy crap. 1 second. Sorry about that. 1-year-olds that like to exercise their voice are always fun. Again, good birth control for all of you. So, all right. Don't ever assume that you're not going to find errors. You will find errors whether you do or not. And if you are the tester, you might easily overlook some things if you plan for just easy success. All right, let's see. So there's this nice probability statement here. And then the last one, which is going to be kind of, interesting to talk about, is that testing is a very hard thing to do, right? Writing code, I've maintained this over the course of the semester. Once you figure out how to write software, maybe it's your first time writing code, maybe you've been writing code forever. it's a mechanical process, right? The creativity is in thinking about how you actually will do it. But just sitting down and writing a program, you learn the syntax. It's just a mechanical, straightforward process to write something. Figuring out how to write it is the tricky part. Figuring out how to test it is even harder because not only do you have to understand how this program works together, you have to understand how to break it and the intricacies of that. So don't take testing for granted, basically, is kind of the takeaway there. All right, we all on the same page so far? Noticing there's only like half of the usual class in my list here, so please feel free to pipe up if you have any questions. Um, if there's like an exam or a homework or something in other classes today that are due. Or Streamlabs just isn't updating. That's also possible as well. All right, so levels of testing. We've kind of talked about this already, right? There's unit testing, integration, validation, system testing. Basically, that's going to be your, and depending on how you look at this too, you might consider acceptance testing at the very end. Basically, you're going from very fine-grained testing to more broader based testing. Right? So we're incrementally moving up in our levels of abstraction here. We've talked about unit testing in great detail, so I'm going to honestly skip over a lot of this. But the thing that is kind of important to talk about with unit testing is that you're actually going to be creating a driver and a stub with these, right? So we looked at stubs a little bit with our traffic light test-driven development cycle, right? That's where you wrote a function, but it did nothing. It was intended to be filled in later. That's what allows your program to actually run because otherwise you'd get a compiler error, function not found, right? The driver is something we did not talk about. That is what is actually going to run your test script, right? So that's effectively like your JUnit runner or something like that. Or how at least you know, instantiate each stub, something of that nature. So again, unit tests we've talked about a lot. I'm not going to go into a lot of detail, but there's one kind of gotcha that I want you all to think about here. I've got a slide due, I think, on the next slide, so I will say be prepared to be asked a question and be stared at if I get no answers. So here we have a unit test that's being performed on some particular class. So we have some test cases. We have our class under test. This class under test has two dependencies. Now, these dependencies could be to other classes, to another package, to some external application. Basically, if you are going to test this particular class, you need to instantiate these two things. Otherwise, it doesn't work. You get an error. Make sense? So what would the problems that you could see with this be? Again, I want you to consider actually that you are testing, let's call this the class under test or the system under test. What about these dependencies? So this isn't really something we've talked about too much yet. And get you some nice dancing emoji there to get you thinking about this problem. Any guesses here? Get you some nice thinking music while we're waiting. It can make you think the problem is somewhere it's not. That's a good guess. So you're testing your class. However, this dependency is throwing a new wrinkle in, right? Class dependency doesn't work, then the test for the main class won't work. Yeah. So basically, this is adding an unknown variable to the equation, right? Think about when you maybe have to do experiments in like your, I don't know, chemistry or physics classes or biology classes where you actually have some physical specimen in front of you and you're doing some kind of a dissection on it or an experiment. You remove all of the extraneous variables that don't impact the situation, right? So you try to remove things that don't impact it. If you have this unknown quantity, it has its little tentacles into your system. How do you know if you're testing your class or whatever weird thing these dependencies are doing? So yeah, it could make you think the problem is either internal or external. You don't really know. You don't really, have a good amount of information there. So let's talk about it in this regard then. So let's actually think about that these dependencies, you're pulling them in is just like a class reference, right? What if they're an interface, to some other massive structure under the hood? Basically, you might have, you brought it in. Maybe you even went so far as to stub it out, basically, so you have um, dependencies that you're testing. And maybe you even have access to those dependencies and you've written little test stubs. However, you have all this extra code, which is basically introducing all kinds of issues. Um, Basically, what you're going to have is just some unknowns that you have to deal with. And in all honesty, it's going to be something tricky that you will have to basically deal with. There's not a super great answer here for what to do because you're dealing with this, maybe a concrete instantiation. You can try to coerce it into your testing model. Maybe you have test cases for these dependencies that you can bring in and try out. But what you're almost dealing with here is basically like an integration test type of situation. Are you bringing in two modules together and seeing if they work or not? Do you also test the dependencies? Do you try to stub them out and try your own class? It's going to honestly depend on your situation that you have. So just something to consider, honestly. Definitions here for you. Basically, drivers and stubs. Again, part of the unit testing process. Just be aware of what they do, and you should honestly be okay. Again, driver, what's going to effectively run your tests and show you the results. Stub, empty function that will make your code actually run so that you can test things out. However, they are overhead that you are introducing here, right? You're adding extra functions, you're adding extra code. There's always the weird question, do your test cases actually impact the system itself? So just by testing, are you adding performance overhead? Are you impacting its behavior? Um, there's a lot of weird things that can go on with testing, basically. So just a little bit more of a visual for you there on stubs and drivers. But again, I'm not going to beat a dead horse too much more with that. I would like to talk about integration testing though, because that is, integration and system testing are part of your final deliverables, right? So we should talk about those. Integration testing, systematic technique. Basically, we are not exhaustively testing our software. We are trying to figure out what are the problems when we bring modules together, right? Is it an interface between the two? Are they now expressing behaviors that they shouldn't be? Basically, does your software work by itself? Unit testing, bring things together, integration testing. And the key with integration testing is that you don't have to do it all in one shot, right? So that's basically called your big bang type of integration where I'm going to take my module, I'm going to bring all of your modules together. We have one big happy program. It's all integrated. We're ready to do a release. Now let's do our integration testing. That is a kind of not good way. It's not really a great way to do testing for integration because you're introducing too many variables in at once. And variables not like programming variables, but just things that can go wrong. Right? If I test systematically and incrementally, like I've got my module and I bring in, say, your module. Then I test it. Does it still work? Yes. Then we bring in another person's module, test again. Then another module, test again. Might take a little bit more time, right? Because you're doing them somewhat piecemeal, but you can account for all of the oddities that happen in a very fine-grained manner. Whereas if you bring everybody's modules together at the same time, it's often really hard to figure out what's going wrong in localized things, right? Because if you can kind of zone in on one particular problem and you correct it, that may introduce a slew of other problems elsewhere that you did not intentionally cause. And you basically get this kind of like ballooning effect that may happen with just testing everything all at once. And it can become a horrible feedback loop and it will become very frustrating for all of you. Honestly, again, it's better to test things piecemeal, like bring them together slowly, test them as you go, kind of a thing. Because I've got this chaos usually the results is a part of Big Bang integration. But again, this is kind of something that we've talked about before as well, right? So basically, we're just bringing modules together and testing them. One thing we haven't really looked at is what do these test cases look like for integration testing? And the answers are going to look exactly the same as your other test cases. The scope is just going to be slightly different, right? If we go back to exit, should just hit F11, but is it going to remember my text? Yes. So if we go down to this test case specification that I showed for you guys, is that going to make it bigger? No. So here we have your basic test case, right? So what's the test case? What's its description? What are the steps for it? Input, output, output, pass or fail. It's going to be identical for integration tests. Now, the steps might be a little bit longer. You know, the input values might be a little bit different because you have more things to deal with, but it's still going to look pretty much the same. It's just looking at your program in a little bit of a broader scope, right? What are the steps? We have to instantiate classes A through C. You have to populate them with this particular data. The expected output is that you now have 3-person entities that have been created with all the attributes from this other module that come in, right? So basically, you're just bringing things together, but you're still testing them in a fairly similar fashion, right? And again, I would recommend incremental integration. It's a lot easier to focus in on your problems as you discover them. If you fix them in a smaller locale, it's a lot easier than fixing them in the bigger scale, right? I know all of you are probably running into that with your term projects where you're probably finalizing things and wrapping things up, hopefully. And you're noticing that little bugs that maybe you ignored all over the place are starting to creep up and cause bigger problems. Um, if you localize them at an earlier stage, they don't cause catastrophic problems later on. But hopefully that's a learning experience if you're seeing that. With incremental integration, we have many different approaches for how to do it. There's top down, there's bottom up, there's sandwich, there's others as well. Basically, all this really means is how do you integrate your software? Now, you can look at it. I mean, it's basically, do you like to go very granular or do you go very broad in how you're going to bring things together? All right, so I've got this kind of weird pixelated figure here, which might not make much sense. But basically, you've got a lot of submodules at the bottom. So very finely tuned small classes or something of that nature. And you start integrating them together. And then you build up a bigger and bigger and bigger system as you integrate. So that's kind of the concept of bottom up. Top down, exact opposite. Start very broad, have maybe a shell of your system as a whole, and then start bringing in the other pieces to flesh it out. So do you start small or do you start big? It's basically kind of the takeaway there. And again, the whole focus here is integration testing. So what you're going to be doing, maybe you start testing out very broadly, and you start working your way down. Or you start very fine-grained, work your way up. Basically, it's just what is your perspective that you're looking at here. The other one is sandwich, also known as hybrid. Basically, you just kind of take ideas from both. Maybe start in the middle. Um, maybe start bottom up and top down, and you kind of work towards the middle. It just kind of depends on your particular flavor of sandwich integration that you want to do. But basically, just start kind of linking things together, and you kind of go almost like a middle out words kind of a strategy here. And when you start looking at integration testing, maybe you don't like my explanation of it, start looking on the web for what is it. Basically get a lot of high level graphics of just visuals like I'm showing you here. Because honestly, you're either starting at a very global perspective or a very fine-grained perspective, and you're just mashing things together and trying to test the resulting um, mishmash of modules that you have there. All right, so here we have a sample test. And notes keep disappearing on me. Question for you here, is this a possible integration test? So we've been seeing a lot of unit tests, right? We did JUnit. Here we have a web server and a web page front end, right? So it's a normal login screen. Give me your email, give me your password, click sign in, send that data to your server, get a response back. And here we have an actual, like a test script kind of a thing. I'm not exactly sure what language this is for testing, but basically should be pretty easy to follow. We're checking the login credentials. Test case, figure out the login path, post some session data to the server, get redirected, assert that what the server returned was welcome to the server with an H1 tag, basically. I see something like this, I expect like a browser tester kind of thing, like a Selenium or something like that. But again, don't necessarily know which language this is. The question though, is this an integration test? Is it a unit test? Is it maybe a system test? I guess I'm curious what you think about that. Any guesses here? That's the new pseudo language. Oh, is that all it is? I guess the point being, though, do you think this could be an integration test? He said as he stared blankly at the class. Doesn't look like it. Well, let's kind of break this apart then. So the answer, as always, in software engineering, it depends. What are we testing here? So we have a front end, we have a back end, we have, some kind of a controller here where we're routing data from the front end to the back end. Maybe this is an MVC pattern. Maybe we're just testing our PHP login form. A unit test, we'd be looking for pretty standard inputs and outputs from some function, right? Or some class. Here, we are taking data from a front end, we are shipping it to a back end, the back end is doing something to it and returning to the front end, right? So we basically have a handful of steps that are happening here. This could be an integration test to me, because maybe we are integrating in our front end and our back end together, right? These are the two modules we are testing. Could be a system test, right? Because this might be the whole system. Maybe this entire thing that you're looking at here, that is the entirety. So we deliver this to the customer. If they give valid login credentials, hey, you're logged in, great. We'd probably have a handful of other tests too, right? Log in with invalid credentials. Log in with valid credentials, but maybe there's a dangling Unicode character that we don't expect. Yeah. So again, it depends is kind of the answer here. It depends on your perspective, right? Hell, maybe you could even consider this to be a unit test if you wanted to go down that route. Maybe this is the most basic functionality of your system. It'd be a little bit harder to argue that, but a well-crafted argument could convince me in a way here. But yeah, you're bringing modules together and you're testing them. So to me, this would most likely be an integration test, if not like a customer acceptance test or something like that. But yeah, you're integrating things here. So definitely good. All right, so what we've been talking about so far has been mainly verification, right? We're testing to our own specifications. Now we get through to the acceptance testing, the validation testing. And basically here, you start trying to get your software ready to release to the world, right? You try to make sure that you're conforming to the requirements of yourself and your customer. Now, here, you really want to focus on what the user is going to be seeing and dealing with. Again, this is what you're going to be showing them that, hey, my amazing phone app works wonderfully. It meets all of your requirements. Here's all the requirements we agreed upon. Everything passes, you're good to go. Right? This is basically going to be your user testing in a way. If you have a customer-centric product, you're probably going to be bringing in users or clients to test upon. Maybe you get focus groups or study groups, or if you don't have to go that route, you're going to be demonstrating through a series of tests that, yes, this works. Maybe you're deploying software to somebody's server and you release it in various phases to their company and you show them that it's doing better than existing servers. It just kind of depends on what your strategy is here. One way you can do that, you can do A/B testing. I think we've talked about this, if I remember right. Um, if we haven't, basically, you're going to have alpha testing, beta testing, can go down to gamma testing. You're probably all aware of alphas and betas for games or softwares where you can get an early access version of it, right? Might still be some kinks that are being worked out, but you're testing things out. Now, the actual definition of alpha testing is where it's going to be typically on your own ground, right? So it'll be done at your particular company or location. Now, the developers will be, looking at some users that are there. Think of it like you're looking over somebody's shoulder, like that second bullet point there, and figuring out what's going wrong. Obviously, that's probably not feasible as much anymore. What you get are like bug reports. You automatically send data to the developer server to scan through a log of everything that's happened. Basically, it's a lot more controlled, is kind of the takeaway here. The developers are still very close to the code in alpha testing. You get to your beta stage, that's probably going to be done at the client site or the customer site. Basically, you're going to release them a software package. You're still going to get data, but the developers are not really there, right? You might be getting fed information from a customer representative or something of that nature. Maybe you get logs or records pushed to you, but the key is that with alpha, generally it is more in-house. Beta, it's kind of pushed out to be tested by, yeah, depending on your strategy, maybe the actual users, maybe a control group, but still that they're aware it's in a testing phase. But again, you would probably have all experienced this in some way, shape, or form, whether it's with phone apps, whether it's with games or websites. Any Google product is always in a perennial beta release, it seems. But you're still feeding information back, right? So that's kind of a very common strategy for acceptance testing. Got a little bit of a nice little graphic here for you to honestly help out with that. But here, I've got another question, another key point to think of here. So alpha testing, there's a point involves both black and white box testing, beta testing, black box testing only. Hello. Why would why wouldn't we have any white box testing at the beta level? So this is another good thing to think about. As I've been kind of, hammering that point home to get used to black box and white box testing. Um, Here it appears again. So question then, why is there no black box testing in beta testing? Question mark. I wonder if typing my questions into the chat would help with some of the delays. Probably would better that way. Any thoughts here? Yep. I guess I should also mention while I'm waiting for, somebody to answer here. There are lots of many different ways to do customer testing. It's not just alpha and beta testing, not just A/B. There's um, I guess there's like red-green testing, there's shadow deployments, uh there's a ton, basically. Hey, great answer. Users can only really test functionality and not the inner workings. Right, so if you remember, white box testing, you know what's happening inside, meaning that you're probably a developer, right? Unless if it's open source and you have a technical expert on site. The customers are only ever seeing your product as a black box. So what they put into it, right, their user inputs, is going to impart some output. That is black box testing, and that's why you do it early on to see basically what the customer is seeing. So that's honestly exactly right there. Hey, this person has a slightly different um, pointer there. Okay, no, good. Last thing we're going to talk about is system testing. And again, it's kind of important to talk about this before we move on to Friday because, again, part of your final. Unit testing, smallest pieces, integration testing, bring modules together, system testing, test everything as a whole package, right? So consider your system to be what you are effectively deploying to your customer. Again, customer could be end users, clients, your professor who's getting your term projects, whoever is basically the stakeholder for your system that is taking it once you're done. So how do we do system testing? Well, take your software as a whole. You probably have like a release candidate or a built application. Everything is in place. All your modules are in there. You've demonstrated that it works with unit testing, with integration testing. Now do it all for the system as a whole. And what do we care about here that's different from integration testing? You care about exercising the system. And what exercising means is that you try it out in a number of different ways to really demonstrate all the different behaviors that can exist. Right? If you only have two modules that you've integrated, that's not the system as a whole. That might be a piece of your system, but it's probably going to be a small piece. So with system testing, basically, again, we're going to have inputs, we're going to have expected outputs. It's going to be tied to requirements, but it's going to be at a broader scale, right? So again, inputs for unit testing, probably pretty small, just parameters for a function. Inputs for integration testing, just whatever is needed to get those 2 to n modules working together. Inputs for system testing, here we have a laundry list of things that have to be set, instantiated, or configured, and then we expect this behavior based on all that, right? So again, the test cases are probably going to look identical in structure, but in content, it's going to be a lot broader. Other thing to consider with system testing as well, you may have events impacting the system. Maybe there's something from the environment that you need to handle, right? Easy example, autonomous cars. Have talked about that over and over again. You drive down the road right now, no problem. Next week, it's going to be covered in snow and you will not be able to see the lane markings. That would be an event that you'd have to handle. And that could be a test that you would configure to exercise your particular system. Maybe it's, your autonomous algorithm that you're trying to prove out. Does it work in snow? Easy test to run, right? So again, we're just going up a layer of abstraction in our tests. The test case will be written the same, just with more content. Now we have a lot of different types of system tests that we can run here. And we're going to basically end on this slide because the next slides are all about your term project. We talked about that last time. But consider all of the different things that you have to test for your system as a whole, right? Test it with a ton of data. Do you have a massive stream of information coming in? Do your data types handle that? Right? Can you handle a terabyte of data coming in if that's what your application needs to do? Do load testing or stress testing. If you're running something where you're accepting user connections, can you handle one user the same as 500,000 users? Is that going to break things? We also care about usability, security. So basically, your clients actually like using it. Does it cause any kind of weird ergonomic problems? Are the buttons in the right place? Do they like the color scheme? Is it secure? Are you encrypting your data? Basically, again, things that you only really think about at a broader scale. Other considerations, performance. Hey, it has to be snappy, it has to run fast, it has to run optimally. You have to be able to store things. So are you storing data correctly? It's maybe it encrypted locally. Is it in a non-readable format? Can you retrieve data? Basically, all of these types of high-level concerns factor in at the system level. And you can demonstrate them at lower levels too. I'm not saying this is only system testing, but these are kinds of the things that you're going to basically be trying to demonstrate to clients and customers. Hey, this is all good to go, right? Um, Other things you might care about without proper definitions here. Is it compatible with older systems, right? If you're developing an Android app, does it work with the past 10 versions of Android or um, Mac OS or Linux or Windows or whatever your system is? Is it reliable? Is your documentation well written? Is there traceability? So on and so forth. Basically, there is just a lot of different ways to do system testing. And one thing you might notice too, now that we're pretty much done for the day, a lot of these almost look like those non-functional categories too, right? I'm not saying that system testing is non-functional only, but they really start to creep in at the system level because that's where everything kind of comes together and you start caring about these, more fluffy aspects in a way. Okie doke, any questions? Otherwise, I will leave you now. I will pop over to the Blackboard, collaborate for office hours, and I will see you all on Friday in a handy dandy Zoom session. So, you all have a wonderful Wednesday. Bye, everybody. See you next time.